The annual Earls Court Show is the global meeting place of the big players in the cable and satellite TV industry. It's a market where leading-edge technology creates opportunities, but must also deliver realities to the mass consumer. The move from analog to digital distribution has meant a time of tremendous technical change for all the players in the industry, from the major satellite operators to the manufacturers of the dishes and the electronics that connect them to the home TV. We'll be looking at how two contrasting set-top box manufacturers cope with this rapidly evolving business environment, beginning with the change in delivery systems. Andy Trott of Pace Microtechnology described the technical background of the recent introduction of digital TV.
The first one to market was satellite, followed by terrestrial. Cable is just about to be launched, and then there's XDSL, which is over the telephone line. All four are a very capable way of delivering television into the home. We will evolve all of those. The one that we're just getting into now is cable TV. They all have merit. Satellite is able to beam into a very wide area, wide footprint, so anyone within that area can put up a satellite dish and receive the television programming. Terrestrial is slightly different in the fact that it receives the pictures through your aerial. Those two both suffer with the fact that they can only have the return to the head end for interactivity via a telephone modem. The other two, which are wire-based, which are the cable TV and the XDSL, do have very high bandwidth into the home, and that allows them to have greater opportunity at the moment to develop content.
Andy is head of technical development for this UK company, the European market leader in set-top boxes. Pace started as a manufacturer of computer modems, but was one of the first companies in the UK to develop and manufacture analog satellite receivers. To date, some 6.5 million analog receivers have been made. They are a public company, based in Bradford at the imposing Salts Mill. This building was originally constructed in the mid-1800s on the orders of Titus Salt, an industrial pioneer. Pace's section of the building houses its design, development and manufacturing divisions, as well as a head office. Altogether, nearly 1,000 people work at the site. Pace has had to change quickly to meet the challenge of the move from analog to digital TV.
It's been a very difficult transition, but a transition that we have evolved over probably 3 years. We started digital television products 4 years ago. We evolved at a very steady pace from analog to digital over 3 years, and then at the beginning of this year, we decided that was it. We're going to stop developing analog TV products. So we actually don't manufacture analog TV products anymore. We have made that transition now from analog to digital. One of the first and biggest challenges that we had was that our research and development department was built predominantly of analog engineers. When we were developing analog TV products, we had 1 or 2 digital engineers that were looking at small 8-bit microprocessors. The software content inside an analog TV product was very limited. You could probably get the code into 8 kilobyte space of a ROM. What we were faced with was moving those analog engineers that we had to digital. It's a whole different kettle of fish.
But it's not just about technical expertise in design.
The other transition has been on the approvals and the manufacturing of that product. The approvals now, rather than taking an analog satellite box home, testing it in a few people's houses and say, right, it's ready for manufacture, we can't do that anymore. We have to go through very rigorous approvals, qualifications, quality checks, and on the manufacturing side, if you went down a production line, it would look like a PC, effectively. It's that type of technology.
The introduction of digital means that the technology can deliver much more than TV into the home.
One of the things that has changed quite considerably in the last 12 months is that the set-top box, as it stands now, which is for the reception of digital television, audio and video services, it's evolved now to have internet content which is quite a breakthrough in terms of internet is now going to become a reality in people's homes. And what that allows is a whole different revenue generator for the broadcaster, the cable TV companies, and it allows opportunities for Pace to expand the base of the product. Various items that we're looking at, for example, voice over IP, which is telephony, which comes in and utilises the very high bandwidth into the home that the internet allows, which is basically built around a cable modem that's integrated into the set-top box. So there's voice over IP, there's internet gaming, there's interactivity in terms of TV on demand, video on demand, a whole host of other opportunities, web surfing, email, chat. That's where the product is going.
Another company caught our eye at Earl's Court, or rather this little chap did. To those in the know, he's famous as the Linux Penguin. He's the mascot for an alternative operating system that is challenging the giants of the PC industry. The incorporation of Linux into this small Danish company's products demonstrates how far the set-top box has evolved in computing power and a willingness on the company's part to be unconventional. And that's exactly what we found when we paid a follow-up visit to the Danish HQ of Force Electronics on the Jutland Peninsula. The company started as importers, but quickly decided to move into manufacturing, as Managing Director Jan Sørensen explained.
When we took the decision, we sat down and we had some quite heavy discussions. How can we survive in a market with very big players like Nokia, Pace, Philips, etc.? What can we do that they haven't thought of? And we thought of some new features, and we had them implemented. This is an analog product. This is the product we're currently selling in Scandinavia, the 2MAC product. What we did is we built it in an electronic program guide, never seen before in analog product. And what it does is it captures all the information from already existing teletext pages.
This information is used to build a 7-day program guide that is contained in the set-top box. The stored information can be sorted by day, by time, or by channel, or even accessed through a database search function. For digital TV, this is the big idea. The Electronic Program Guide, or EPG as it's now known in the business, offers the viewer guidance through the increasing number of TV channels.
It will be personalized. You will, for example, enter issues that interest you. That could be anything from sports fishing to kangaroos in Australia. Issues that interest you, and the EPG will automatically find the programs you're interested in. Remember that we're probably talking about, who knows, 1,000 channels within the next couple of years. They're each transmitting 10, 20 programs every night. How are you going to find your way around in that? You'll have a printed program guide in the size of a telephone book. The EPG is the way, it will be the browser to find your way around in all those programs.
Commercial success in this business depends upon being clever. Not only clever about the features of the product, but also getting the technical details of design and production right, as Joint Managing Director Jesper Kargaard explained to me.
What do you see as the major challenges facing you over the next 5 years in satellite reception?
At the current product right now, we have done a lot to accommodate production and staying or having as low cost as possible. If we have a look at our competitors' products first, we see that the design is quite old-fashioned, using older types of components. And if you look at the amount of components, you see that both sides of the board has been used, which is a complex production method and quite costly.
A lot of components on that as well.
Yes. If we have a look at the board we design, we use modern methods. lesser components and simpler production. A lot of the SMD components which can be mounted by machines. And again, to facilitate production, we don't have anything on the bottom side of the board.
The first processes in the manufacturing sequence involve placing a variety of components, including surface-mounted devices, SMDs, onto pre-pasted circuit boards. With boards of this complexity, components of this size, and tolerances of less than a millimetre, assembly can only be successfully achieved economically by using pick-and-place units of this type, incorporating optical positioning technology. How does Force decide which technologies to focus its attention on?
An easy example is that you don't want to make the silicon chips yourself. It involves very huge investments. When you reach volumes of millions, you would consider to have something done in custom design, but you will not build the factory. The actual PCB, a complicated process again, which are highly specialized work, which some companies are very good at. Tuners, modulators are coming onto the boards now. One of the really muddy things is the power supply. The power supply is a very critical component, and you really have to choose between in-house value, where you know your design and quality level, compared to the cost of doing all this, with approvals and all other kind of measurements.
The printed circuit boards, with their mounted devices, are then put through a process that reflows the solder and establishes the circuits. Does Force undertake a make versus buy analysis for critical aspects of the technology that it uses?
We have to control the technology. We have to know what we're doing, not to slip away from the actual control of the product.
So where you think you've got a critical aspect of the technology, it's important to you to keep that under your own control.
Yes. That might be sole source components. You really are considering that before you buy a component which can only be supplied by one company.
Yeah.
It's always a bad situation.
To show up any mispositioned components or circuit problems, the partially completed board is tested. A set of pins, known as a bed of nails, makes contact with various points on the circuit to validate its integrity. This is followed by a visual inspection. No matter how clever the design of the PCB, it will always contain some components that, for a variety of reasons, have to be assembled by hand for later soldering. One of the advantages that small companies have over their larger competitors is flexibility. How does Force achieve this?
One thing is the chain of command, or the people who have to get together to make a real decision. This can be done very fast and very efficient. Another thing is that the rigid structure of a larger companies, with defining products, who's taking the responsibilities for the different development phases and so on, is much less rigid in a small company.
The completed board is then partially assembled into the case and is ready for programming. This is not only to make the machine function, but differentiates varieties of the product. Depending on the amount of memory on the board and the software downloaded into it, a range of features can be incorporated into the set-top box. As the computing power on the board increases, further enhancements can be made at this stage in future.
We've added some new functions in this board, like programmable hardware, updating the software and channels and so on. and generally had a more powerful processing platform for mobile development. It facilitates easier development and gives more security that the program will actually run correct when they are put in the field.
One example of this, already incorporated into the existing product, is the ability to send messages to users through private teletext pages. But force our thinking beyond this.
One of the major changes is that you can actually buy a product today and have upgrades in the future. You have new functionalities added in the future. So you're not just buying a one-off product which you'll throw away in 1 or 2 years' time. You will actually get more benefits for a period of time after you bought the equipment.
As an example of this type of upgrading, a teletext page is also used to program the existing models. At 5 o'clock in the morning, each set-top box tunes into the page and downloads information to update the tuning details and channel identification for the satellite receiver, foreseeing this an element of future-proofing for the product.
It's both a future-proofing, but it also really enables you to download new functions like enhanced electronic program guide or whatever we might come up with in the future.
After testing the infrared remote control and internal calibration on the factory bench, the box is finally screwed together, and all that remains is to pack the completed boxes for transport to the customer. The obvious change for both companies in the move from analog to digital is that the set-top box increasingly relies on software to make it work. How much effort is needed to develop the software?
Wow, that's a very difficult one to quantify. We often will have a 9-month development cycle for developing a set-top box. We have up to 20, maybe more than 20 engineers developing the software for a set-top box. So you're talking in the order of 15 to 20 man-years of effort.
The hardware design itself is the shortest part of the project. It might take a person 3-4 months to design a board, make the layout and make it ready for production. And you might add features to this product by software by having 6 or 7 persons working for more than a year to add the software needed for this board.
So 6 to 7 times the resources go into the design of the software as go into the design of the hardware.
Yes, at this point, but it's increasing. I would say that a suitable ratio for modern products would be 1 to 10.
As the digital TV set-top box becomes more and more like the PC market, a larger and larger content of the box is software. If you look at the intellectual property content, probably 60-70% of the intellectual property content of the set-top box is software. That means as a company we are very heavily involved in the software development. And to get the software right is a very, very difficult thing. If you take the PC, a good example, and how many times your PC crashes, you can't accept that in a digital set-top box whilst you're watching television. So consequently we put a huge amount of effort in the software development process. And that goes through many iterations of developing the code, field trialing, approving, and maybe retweaking prior to releasing that product into the market. So it's a very complex process.
The most significant business development at the time of the Earls Court exhibition was a decision by the 2 major UK digital TV providers, Sky and On Digital, to offer the set-top box for free as part of the subscription deal. For Pace, whose box is one of the models included in the deal, this meant good news, but not for Force.
That's a difficult one to handle, of course it is. But again, let's take an example like France. Something like 6 million set-top boxes is already installed there. If just 1% of those customers want something different, remember that the boxes they have now, the only difference is the name on the front of the box. The user surface, software, everything is the same in those boxes. if just 1% of those 6 million people wanted something different, in features, surfing on the internet, connecting an alarm system, using the television as a monitor, monitoring the temperature in the house, etc. Well, there's a niche market for us.
Both companies have to contend with another possible technical change, the eventual disappearance of the set-top box altogether, as TVs come onto the market that contain the digital decoding circuitry within the set, the so-called Integrated Digital TV, or IDTV. Would this be a threat to Force's market?
No, I don't think so, because I think a good argument is why aren't the VCRs incorporated in televisions? Well, they are, but it's not what sells. I believe it's something like 1 or 2% of the market for televisions.
A year ago, when IDTVs were forecast to, some forecasts were that they were going to take over from set-top boxes, we as a company weren't sure which direction was going to be the successful direction. So what we decided to do was to hedge our bets and get involved in both. And we took the Intel model, Intel Inside, and we developed a digital TV module that we made available to any TV manufacturer that wanted to integrate that into their TVs. And that is our business model. We use that philosophy. We take our digital technology that we are very good at integrating. We work with the broadcasters, Sky, On Digital, Cable and Wireless, all the UK companies. We work with the companies and broadcasters on continental Europe. We can take that technology, put it into a form that goes into TVs. And whilst at the same time we do that, we also keep the set-top box development progressing as fast as we possibly can.
To round off this story of how two companies are meeting the challenge of a changing environment, we asked each of them to sum up their strategic approach.
We are technology driven. We don't know what we'll be doing in the next 2 years. We look at the possibilities and the new technologies, and we take the technology to the edge. When we launch a new product, our competitors will normally see us as jumping over the next 1 or 2 generations of products. So we want them to follow us, we're not following them.
We are #1 in Europe. We've just had figures announced to say so. And we're #4, #5 in the world. So we've got a few rungs up the ladder to go before we reach our magic #1, but we will get there.